All right, so we're going to do 17.4 absolute value inequalities. And so we're not going to do the second one because honestly, this one is better. And then we're going to go ahead and do 1 and 3. That's what we're going to do. So we know that if the absolute value of of x is equal to a, so the two possibilities is that x is equal to negative a or a, right? Now, what happens here is that if the absolute value of x is greater than a, there are two possibilities. Either a is less than negative a, or x is greater than a. And so when you solve these, you're going to have to end up, writing it this way in absolute value symbol. Now, if it would have been the absolute value of x is greater than or equal to a, then I would have had that a is less than or equal to negative a, or x is greater than or equal to a, at which point you would write your absolute value, your interval notation such as that. And of course, this is a similar thing here, where if the absolute value of x is less than a, then there's two possibilities. It's either between those two. So of course, we already know that we can write this in interval notation just like that. We did that in previous sections. So here we have absolute value of 3w plus 1 is minus 4 is less than 7. So we're going to add the 4 to both sides. And we get the absolute value of 3w plus 1 is less than 11. So if it's less than, we're going to have negative 11, 3w plus 1 is less than 11. So I'm going to subtract 1 from all three sides, which gives me negative 12, less than 3w, less than 10. If I divide everything by 3, I get that. And then, of course, we're going to end up with negative 4 is less than w, is less than 10 over 3. So if we write it in interval notation, it's going to be negative 4, 10/3. Let me make sure I can come back here to my 17. Sorry, it's froze up on me here real quick. All right. And so here again, we're going to go ahead and subtract the 2 from both sides first. So the absolute value of 2t plus 5 is less than or equal to 9. And so since it's a less than, it's going to be negative 9 less than or equal to 2t plus 5 less than or equal to 9. Subtract 5 from all three sides. Negative 14 is less than or equal to 2t less than or equal to 4. If I divide everything by 2, I get negative 7. It's less than or equal to t. It's less than or equal to 2. So when I write it in interval notation, we're going to use the brackets. Here, same thing. We're going to subtract the 1 from both sides. So I get 2 is less than or equal to 1/2 t minus 5. Now, if I flip this, I'm going to end up with absolute value of 1/2 t minus 5 is greater than or equal to 2. So if it's greater than, it's going to be 1/2 t minus 5 is less than or equal to negative 2. Or 1/2 t minus 5 is greater than or equal to 2. So I'm going to add the 5 to both sides. So I get 1/2 t is less than or equal to 3. And if I multiply by the reciprocal, which is 2, I get t is less than or equal to 6. Here, if I add 5 to both sides, I get 7. And if I multiply both sides by the reciprocal again, then I get t is greater than or equal to 14. So then what happens is, if I do my number line from 6, and I'm going to put 14 here, it goes from the 6 over this way because it's less than, but at the 14, it would go that way. So if I write it in interval notation, it would be negative infinity, 6, union, 14 to positive infinity. So you have that gap between 6 and 14. That one's extra for you guys. So here's another example. We're going to subtract 7 from both sides. So the absolute value of 3d minus 5 is less than negative 3. So absolute value is always positive, so there's no solution because it cannot be less than a negative number, right? Here's another example. So I subtract 7 from both sides, and I get the absolute value of 3d minus 5 is greater than negative 3. So since the absolute value of 3d minus 5 is always positive, it's always going to be greater than negative 3. So in this case here, we have all real numbers. That one's extra for you guys. Okay, so here again, this is always going to be greater than, well, in here, we're going to solve it this way. I'm sorry, I should have. So it doesn't make any sense to solve it for less than or equal to 0, because 0 is not either positive or negative. So I'm going to subtract the 2 from both sides, divide by x, and I get negative 2 over 4. So x is greater than 2, negative 1/2. So then the answer would be, including negative 1/2 all the way to positive infinity. And here again, is it always greater than 0? Yes, so then this is all real numbers. Now, if you think about it, if I do greater than 0, and I subtract the negative 2, and then x is greater than negative 1/2. Sorry, I misread that one. So then x is greater than 1/2, negative 1/2 here. It's the same thing. Now, the thing about this one is that it could be greater than or equal to 0, and then this one here is that it's always greater than 0. So it could be equal or not, right? And so either one. All right, here, can it be less than equal to 0? No. Well, it could be equal to 0, so I can do absolute value of 4x plus 2 is less than or equal to 0. I subtract the 2 from both sides, and I get that x is equal to this. X is equal or negative to negative 1/2. So then, the thing with this one is that it could be equal to 0, but it cannot be less than 0. And so you got to be careful with that one. All right, we'll skip these 3 examples. We're going to skip those there. And then I'm going to skip those. Those are the test point 1. It doesn't make any sense to do that. And then we're going to translate these. So here, all real numbers x whose distance from 0 is greater than 5 numbers. So we're going to write an absolute value inequality. So the absolute value of x, and it says greater than 5 units, so then it's greater than 5. Here, all numbers x whose distance from negative 7 is less than 3 units. So it's going to be less than, absolute value of x minus 7 is going to be less than 3. And that's extra credit for you guys, and that's the end of 17.3. 17.4, thank you.